Hello dear students, welcome to Physics Maestro YouTube channel. In this video we will be learning about the chapter calorimetry, and this is this video is the lecture number 2. In the previous session video we learnt about the chapter calorimetry, and in that we learned something about the concepts of heat and its units, temperature and its units. So in this video we will be learning the important important concepts of the chapters. So that includes factors affecting the quantity of heat absorbed to increase the temperature, specific heat capacity and its units, thermal capacity or heat capacity and its units, and the relationship between specific heat capacity and thermal capacity. So these are the 4 concepts that we will be learning today in this video. And so before starting today's class, okay, so let us recall all those things which we studied in the previous session video. Okay, fine. So as I told you, we learned about the concept heat. What do you mean by heat? Heat is a form of energy that flows from hot body to cold body. Heat is a form of energy that flows from higher internal energy to lower internal energy. So this is a simple definition of heat. Okay, fine. So there I mentioned something called as internal energy. What do you mean by internal energy? Internal energy is also called as thermal energy. So this, in order to understand this internal energy, we need to know the behavior of atoms and molecules inside the substance. So every substance are made up of atoms and molecules, and these atoms and molecules will be in 2 states. One is they will be in rest state, and other one is they will be in a random motion. So the rest position possesses the potential energy, and the random motion will possess the kinetic energy. The combined effect of this kinetic energy and potential energy will give rise to a special type of energy which is called as the internal energy, and that is also called as thermal energy or heat energy. So all these things we discussed in the previous video. And the SI unit of heat energy is calorie or joules. There is a relationship between calorie and joules. 1 calorie is nothing but 4.2 joules. And then we came to know about the temperature. Okay, temperature is a parameter which gives the thermal state of a body. Okay, so temperature is nothing but it is the parameter which says which body is more hotter than which other body. Okay, fine. The simple definition includes temperature is nothing but it is the measurement of degree of hotness or coldness of a body. Okay, fine. So the SI unit of temperature is Kelvin, or sometimes we will be using degree Celsius. There was a relationship between Kelvin and degree Celsius. So temperature in Kelvin, if we want to get, if we measure the temperature in degree Celsius, then we have to add a constant value, that is 273. These things we learned in the previous class. So in today's class, as I told you, we will be let us concentrate on factors affecting the quantity of heat absorbed to increase the temperature, which is very important. Okay, so for problematic point of view, so in complete one video I cannot complete all the concepts, and I cannot handle this what are the problematics. Why? Because it requires more time. Hence I will complete all the theoretical concepts one by one, and then we will move on to the problematics in the coming videos. Okay, fine. So I request all of you not to skip the video. Why? Because if you skip the video, you will not get the clear information about the concepts which is mentioned as per the syllabus. Okay, so it is very difficult to solve the problems unless we know the basic concepts, basic things which need to be understood. Clear? Yes, fine. So in that, first concept is what? Factors affecting the quantity of heat absorbed. So what do you mean by this? What are these factors? Okay, so let us understand what is the meaning of quantity of heat absorbed. Okay, fine. So consider, if we want to increase the temperature of any body, consider any of the body. If you want to increase the temperature of the body, we have to give some heat energy. Okay, we have to give some heat energy. That means that body will absorb some amount of heat. So how much it will absorb? So that amount of absorption depends on some factors. Okay, fine. So we will discuss those factors today. Importantly, okay, so there are 3 factors. How many factors? 3 factors. First one is what? Mass. Okay, fine. Second one is the rise in temperature or change in temperature. The second factor is rise or change or increase in temperature. Okay, and the third one is the nature of material, nature of material, nature of material. Okay, so these are the three factors on which the absorption of heat depends. Okay, consider, let us understand how this mass can be called as a factor of heat absorption. So let us take the example. Why? Because these are all the theoretical concepts which we need to understand, hence we have to consider some examples. Without examples it is very difficult to understand. So let us take example. Let us take 2 beakers of water, and so the mass of water which present in the 2 beakers are different. Okay, fine. So consider here in this beaker 2, this is beaker 2, this is beaker 1. In the beaker 2, there is 2 kg of water. So as we know that water can be measured in terms of water can be measured volumetrically, but here I am using it in terms of what? Mass. Okay, so why? Because okay, we can measure the water in terms of mass also, no problem. Okay, so no worries in that. So here in the beaker 1 we will be having how much water? 1 kg of water, 1 kg of water. Now I will just keep on increasing the temperature here by putting the fire. So that means by giving the heat energy, this fire will give the heat energy. So here I am giving the heat energy. Heat energy is a physical quantity, hence it is mentioned with the help of letter Q. So if I put the fire, okay, see here, since the mass, okay, so if I leave it for 10 minutes, if I leave it for 10 minutes, okay, so here the amount of, okay, so here the temperature will be greater than this temperature. Okay, try to understand, and you can imagine this one also. So if I put the fire for 10 minutes for both the beakers, which is having 1 kg in beaker 1, 1 kg of water in beaker 1 and 2 kgs of water in beaker 2, after 10 minutes, if I look into the temperature with the help of a thermometer, okay, so the temperature which is there in 1 kg of water will be more than 2 kg of water. Okay, so why? Because here in both the cases the amount of heat energy that is given here are same. Okay, so same amount of heat energy we have given, but since here mass is less, here mass is more, the amount of heat energy, okay, so that is absorbed by this mass, more mass will be less. Why? Because mass is more. Here the amount of heat energy required by this 1 kg of water will be more. Why? Because mass is less. Okay, so that means to rise the temperature of the quantity of any substance, okay, so that amount of heat energy depends directly on the mass. So if the mass increases, then the amount of heat energy must increase. The amount of heat energy that we will give must increase. So here for 1 kg of mass, okay, so we are giving 4 flames, that means less amount of heat energy, but for 2 kg of mass, after 10 minutes, if I want to get the same temperature value, then I have to put some more fire to this the 2 kg of water. So by this we can conclude that so the quantity of heat energy absorbed depends directly on the mass. As mass increases, so to get the same value of temperature, we need the more amount of heat energy. More mass means more amount of heat energy will be absorbed. Clear? Yes, fine. So the second factor is rise in temperature. Now let us consider. So here the mass is different, okay, but the substance is same. So here substance is what? Water. Here also substance is water. Mass are different. Okay. Now let us consider the mass as same. Okay, so the mass will be same. The substance are same. The substances are same. The mass are same. Okay. Here I am giving the heat. Here also I am giving the heat energy. Here the mass will be 1 kg. Here also the mass will be 1 kg. Okay. Fine. So in order to rise the temperature, here I want to rise the temperature. Okay, so here let me take the temperature will be, initial temperature will be 23 degree Celsius. So that means the final temperature I want to get what? 33 degree Celsius. Okay, so the mass are same, the substance are same, but here the temperature that I wanted to rise is 23 from 23 degrees Celsius to 33 degrees Celsius. That means 10 degrees Celsius of temperature I need to rise. Here I want to rise, Okay, so 20 degree Celsius. Here temperature 1 will be 23 degree Celsius. I need to rise up to 43 degree Celsius, not to 33 degree Celsius. Here 43 degree Celsius. Here for both the cases I will give same amount of heat energy. After 10 minutes, I may get 33 degree Celsius, but I will not get 43 degree Celsius. Clear? Yes. So why I will not get 43 degree Celsius? Why? Because here the amount of heat energy that I am giving for 10 minutes is same for both the cases, but here I require more temperature. Okay, so that means more amount of heat must be absorbed by this water. Here less amount of heat must be absorbed by this water. Here I may get the result as expected, but here I will not get the result as expected. Why? Because for both the thing I am giving the same amount of energy. So in order to raise the temperature within the same timings, so to get the more value of temperature, I must give more amount of energy. If I put some more amount of fire here, okay, some more amount of fire, that means if I give some more amount of heat energy, then there is a chance that I will get what? Up to 43 degree Celsius. Okay, so here the change, that is rise in or change in temperature, will be denoted with the help of delta T. So that delta T depends directly on heat energy, or heat energy depends directly on temperature, change in temperature. If I want to raise the temperature, I must need more energy. Okay, so by this we can conclude that, so the amount of heat energy or amount of heat energy absorbed will be directly proportional to the change in temperature. Clear? Yes, fine. So next one is what? Nature of material. Here nature of material, here what I will take? I will take two different substances of same mass. Two different substances of same mass. For example, let me take, in first beaker let me take water, okay, in the other beaker let me take copper. So copper is a metal, water is a water, okay, so liquid material. So usually water will be in the form of liquid, copper will be in the form of solid. Clear? Yes. So if I put this water, 1 kg of water, here also 1 kg of water and 1 kg of copper, 1 kg of copper. Now I will give same amount of heat. Okay, so this arrow marks will say that if I write 4 arrow marks, that means I am giving same amount of heat energy. Clear? Yes, fine. So if I give same amount of heat energy and if I leave for some time, okay, so this water, okay, so this water, the temperature of the water may rise to 100 degrees Celsius. Okay, the temperature of the water may rise to 100 degrees Celsius and it will start evaporating. Okay, so and it will start evaporating, but in copper what will happen if it rises to 100 degrees Celsius? So the copper metal will not get evaporated, so it will not change its state from solid state to liquid state only. So or else what will happen? At home we can what? We can convert this. If this one happens, means that means for the same amount of heat energy, if copper also converts it into vapor stage, then at home only we can we can convert this solid material into liquid material and gaseous material. Correct? Yes. So different substances will have different melting points. Why? Because the material is only different. The amount of heat energy that is absorbed by those materials are different. Why? Because the materials are different. Clear? Yes. So why? Because each and every material will be having a different specific heat capacity. Okay, so there comes one more the constant or the physical quantity, which is called a specific heat capacity. Okay, specific heat capacity. So this specific heat capacity will defines the substance. Which substance is this one? So that one will be defined by what? Specific heat capacity. There is a constant value called as specific heat capacity, and that specific heat capacity will be different for different substances. So for water there will be different value, for copper there will be different value. So the different values will define which substance is that one. Clear? Yes. So here if the material changes, the amount of heat energy required for its absorption also changes. Okay, fine. For the same amount of heat energy that is given, for example, the water will absorb 100 times more than the copper. Okay, so this water will absorb 100 times rapidly, it will absorb this heat energy than copper. Clear? Yes, fine. So hence by this we can conclude that the quantity of heat energy or the quantity of heat energy absorbed depends directly on mass. The quantity of heat energy absorption depends directly on the rise in temperature, and it depends on the nature of the material. It depends on the nature of the material. So by considering these three, let us conclude these concepts. Okay, so if I want to conclude this concept, so I came to know that the heat absorption depends, okay, the heat absorption depends directly on the mass. The heat absorption depends directly on the change in temperature. So if I want to combine this one, okay, I can combine. Why? Because LHS is same. So if I combine this one, Q is directly proportional to M into delta T. Clear? Yes, fine. So in physics, mathematics or physics, so we cannot equate any equation, or we cannot solve any problematics with the help of this equation. So if I want to convert this expression as equation, I must equate it to some value. If I convert this proportionality symbol into equal symbol, then I must include some constant of proportionality or proportionality constant. Here that constant of proportionality is nothing but what? Specific heat capacity, which is denoted by small c. Okay, like for example, in force chapter we will be having force is directly proportional, gravitational force is directly proportional to the product of masses. Gravitational force is directly proportional to the square of the distance between them. If we include this one, if we combine this one, it will come as m into m divided by d square. So we will remove this proportionality by including a constant of proportionality, which is gmm divided by d square. So this one is 9th standard concepts. So I think here this g acts as what? Constant of proportionality. So which is nothing but universal gravitational constant, and it will be having the exact fixed value here. Okay, so but here the specific heat capacity depends on the nature of material. So hence it is not a fixed value here, where C is equal to specific heat capacity, and it is different for different material. So the specific heat capacity will be different. Okay, for water the value will be different, for copper value will be different, aluminum value will be different, and wood value will be different. So like that it depends on the material. Clear? But here in this formula this G will remain same. It is universal gravitation, that's why it is called as universal gravitational constant. Clear? Just to make you to understand why this if we remove this proportionality symbol, equal symbol will come. Okay, so to make you to understand, I took this example, that's it. Clear? Yes, fine. So this is nothing but what? The equation for heat energy. Okay, so heat energy is nothing but what? It is the multiplication of specific heat capacity into mass into the change in temperature mathematically. Clear? Where here C is nothing, small c, this one is not capital C, this one is small c, that we need to understand. Okay, so C is nothing but what? Specific heat capacity. So these are the factors affecting the heat energy absorption for or to raise the temperature of an substance. Clear? I hope you are very clear with this. Now let us move to the next concept, which is called as thermal capacity and its units. Okay, fine. So let me rub this one. I think you are very clear with this. If you have any doubts, just please put me a message on the comment box, so that I will clear that one for you. Okay, fine. So let me rub this one. Yes, the next concept is what? Thermal capacity or heat capacity. Thermal capacity or heat capacity. So what do you mean by this thermal capacity or heat capacity? So why we need to learn all these things? Why? Because these are all the terminologies in order to understand the concept of heat or calorimetry very clearly. So as we know, okay, so for example in mathematics, if we take the circle, okay, we must know some terminologies like circumference, radius, okay, diameter, tangent, secant. Okay, so these are all the terminologies, the terms which we need to understand in order to deal with this circle concept. Okay, so why we have to know this one? Okay, so to solve the problem, if we get any questions on this circles concept, simply, okay, fine. So in the same way, there are some terminologies in the calorimetry chapter also which we need to study in order to solve the problematics questions. So here thermal capacity, it is nothing but it is the amount of heat, it is the amount of heat energy required to rise the temperature, to required to rise the temperature of a substance to 1 degree Celsius or 1 degree Kelvin. Okay, so consider any substance, any object, let it be solid, liquid or gaseous, let it be any object, water, copper, aluminum, iron, any of the object. Okay, if you want to rise the temperature, by 1 degree Celsius, or 1 degree Kelvin, consider the initial temperature will be 23 degrees Celsius. I wanted to rise it to 24 degrees Celsius. The change in temperature will be how much? 24 minus 23, which is nothing but 1 degree Celsius. In Kelvin scale also, how much it will become? That is, okay, so 273 plus 23 minus 273 plus 24. So, in temperature Kelvin, how to convert this into temperature Kelvin? So, 273 plus 24 minus 273 plus 23. So, if you go for cancellation, then also we will get what? 1 Kelvin only, 1 Kelvin. So, to rise the temperature of any of the object, okay, to 1 degree Celsius, how much amount of heat is required? That is nothing but what? Thermal capacity. Okay, so mathematically we can write it as what? Thermal capacity is equal to, see here, it is the amount of heat energy. It is the amount of heat energy. For what we need that amount of heat energy? To rise the temperature. Rise in temperature to 1 degree Celsius. So hence mathematically this thermal capacity we can write it as thermal capacity is a physical quantity, hence it will be having its own denotation, and the denotation of thermal capacity is what? C dash. C dash is the denotation of thermal capacity. This is capital letter C. Okay, so as we know that there is no prescribed textbook for ICSE syllabus, so we can depend on some publications. The book that I am referring to explain all this concept to you is Selina Publishers. So hence in that, according to the textbook, so I am just explaining the concepts. So hence, so there also we can take different letters, capital C only, okay, so or capital C dash, okay, so like that, C cap, like that we can take different things, but in the textbook it has been mentioned there, and that will be familiar. Why? Because so those who are just referring those textbooks, so they will feel what? Familiar if I use the same words. In that, keeping that in mind, I am using this same letters. Okay, fine. So C dash is the thermal capacity denotation. So heat energy, as we know that the denotation for heat energy is Q. Rise in temperature, which is nothing but what? Delta T. Okay, so this is the formula for what? So thermal capacity or heat capacity, both are nothing but one and the same. Okay, so now I think you are very clear with the thermal capacity. Now let us go with what? SI unit. SI unit of thermal capacity, okay, is equal to, see what is the SI unit of heat energy? Okay, so it can be joules. What is the SI unit of change in temperature? It can be degree Celsius or degree Kelvin. Joules per, let us take SI unit Kelvin only, or or if we take the heat energy in terms of calorie, so calorie per Kelvin, or else we can take it as joules per degree Celsius or calorie per degree Celsius. So whichever you take, so that will be correct. So these are the units. Okay, so these are the units for thermal capacity. Okay, so it can be joules per Kelvin or calorie per Kelvin. It can be joules per degree Celsius or calorie per degree Celsius. So the main thing is, if they give in calories, we have to convert it into joules, which is nothing but 1 calorie is nothing but what? 4.2 joules. That's it. Clear? Yes, fine. So these are the units of what? The thermal capacity. I hope you are very clear with thermal capacity and its unit. Now let us move to the next concept, which is nothing but what? Specific heat capacity. Okay, specific heat capacity. So before that, let me write the thermal capacity formula. Okay, so here I will write. Why? Because in future, in the coming concept, I want this one, thermal capacity C dash is equal to Q divided by delta T. Okay, so from factors on heat energy, we came to know that Q is equal to M into C into delta T. Okay, so these two are the formulas or mathematical equation. So far we concluded. Now let us move to the next concept, that is a specific heat capacity. So specific heat capacity. So as we discussed in the factors affecting the heat absorption to raise the temperature, so there also we came to know that a specific heat capacity, which is denoted by small c. Okay, so from the factors affecting the heat absorption to raise the temperature, so we came to know that the amount of heat energy will be equal to M into C into delta T. Okay, so here we got this specific heat capacity. C, we can write it as Q divided by M into delta T. So like this we can write. So now let us define what do you mean by this specific capacity. Okay, so definition says that it is the amount of heat energy. So slight difference is there. So except that thermal capacity and specific heat capacity are okay. So in definition wise it looks similar, but a small difference is there. So it is the amount of heat energy required to raise the temperature of a mass of an object or substance to 1 degree Celsius or 1 degree Kelvin. Okay, per unit mass. Okay, so there the mass may be different. Okay, so in thermal capacity the mass is not particular. Okay, it does not depend on mass. Okay, it just depend on the substance. But here, so this specific heat capacity is very much dependent on substance and unit mass. That is the simple difference. It is the amount of heat energy required to raise the temperature of a substance to 1 degree Celsius or 1 degree Kelvin per unit mass. Okay, fine. So this is the simple definition for what? Specific heat capacity. And specific heat capacity has the formula, that is Q divided by M into delta T. Okay, so this is the formula for what? Specific heat capacity. Now let us define the SI unit. SI unit of specific heat capacity, which is C. Okay, so that includes, see what here also we have to, if we want to get the SI unit of specific heat capacity, here also we have to write in terms of what? SI units. What is the SI unit of heat energy? That is okay, so we can take in terms of what? Joules divided by what is the SI unit of mass? Kg. Okay, into kg into what is the SI unit of change in temperature? It may be degree Celsius or it may be degree Kelvin, or I can read it as joules per kg Kelvin. joules per kg Celsius, joules per kg Kelvin. This can be written as joules per kg per degree Celsius or joules per kg per Kelvin. Okay, fine. So this is what? This is the unit of specific heat capacity if we take the heat energy in terms of joules. The same thing if we take the in terms of what? Calorie means calorie per Kelvin per degree or calorie per kg per degree Celsius, calorie per kg per Kelvin. So this will be the different units of what? Specific heat capacity. Clear? Yes. So these are the things which we need to learn, which we need to memorize, the SI unit of specific heat capacity and formula for that one and the definition for that one. I hope you are clear with this. So now there is a relationship. See here, I will write it here as specific heat capacity. Specific heat capacity. Here we got C is equal to Q divided by M into delta T. Now let us combine this one. The next concept is what? The relationship between thermal capacity and specific heat capacity. If we combine that one, okay, so see here, I will write relationship between specific heat capacity small letter c and heat capacity capital letter C dash. Okay, fine. So from the factors, from the definition of heat capacity, we can conclude that C dash is equal to what? C dash is equal to Q divided by delta T. Okay, Q divided by delta T. But from factors on which Q depends, we have Q is equal to MC delta T. Q is equal to what? MC delta T. Just put the same value here. Therefore, C dash will become what? In the place of Q, what you have to put? MC delta T divided by delta T. Okay, fine. So this here, see here, delta T and delta T will get cancelled. C dash is equal to M into small c. Okay, so this is the relationship between the specific heat capacity and thermal capacity or heat capacity, or okay, small c is equal to capital C dash divided by M. This is where, so the definition says, so it is the amount of heat energy required to rise the temperature. C dash is nothing but what? It is the amount of heat energy required to rise the temperature per unit mass. Okay, so C dash means it is the amount of heat energy required to rise the temperature to 1 degree Celsius per unit mass will define the specific heat capacity. These are the relationship between specific heat capacity and thermal capacity. Very, very important. Okay, so why? Because in the problematic question, sometimes they will give thermal capacity and mass. We have to calculate specific heat capacity. Sometimes they will give specific heat capacity and mass. We have to calculate thermal capacity, and then we can go for what? Amount of heat energy. So like that, so every concept depends on other concepts. Okay, so it is very, very important. I think you are very clear with this relationship between the specific heat capacity and heat capacity. So far we discussed 4 concepts. One is factor affecting. So the factors affecting the heat energy absorbed to rise the temperature, it depends on 3 factors. One is the mass, second one is change in temperature, and the third one is nature of material. There we got one equation, Q is equal to MC delta T, where M is mass, C is specific heat capacity, delta T is nothing but rise in temperature. Okay, fine. So in the second one, thermal capacity, it is the amount of heat energy required to rise the temperature by 1 degree Celsius, and the definition is like this. And the SI unit of thermal capacity is what? Joules per Kelvin, calorie per Kelvin. Next, factors on which okay, so this one we completed. So next, specific heat capacity, it is the amount of heat energy required to rise the temperature per unit mass. To 1 degree Celsius per unit mass. Okay, fine. Now just to make the things very clear, okay, so I'll just check whether whatever the concept we got is true or not. Okay, whatever the things which we discussed here so far are true or not. How can we conclude that? Yes, just listen here. Okay, so Q is equal to what? MC delta T. Correct? Yes, fine. What is the SI unit of heat energy? Joules. If we take in terms of heat energy in terms of joules, here also we have to consider the specific heat capacity in terms of joules only. So in the SI unit form, if we calculate any value, the SI unit must remain same. The RHS must also give the same unit. Let us cross check. What is the SI unit of mass? Kg. What is the SI unit of specific heat capacity? Specific heat capacity says that joules per kg Kelvin. I will take the temperature in terms of what? Kelvin. Here we have to take joules. Why? Because here also we consider joules. If we considered here calorie, here also we have to consider calorie. Clear? Into what is the SI unit of that is temperature? Kelvin. See here, kg cancel, Kelvin cancel, hence joules will be equal to joules. So hence the concept is very clear. Okay, fine. Next one, the same thing, let us include the thermal capacity. Q is equal to what? MC delta T. But MC means what? See here we can say, see here, I'll just take this M towards this side. M into C is equal to Q by delta T. Okay, Q by delta T is what? C dash. So C dash is equal to MC. So instead of MC, I can write it as what? C dash into T. What is the SI unit of this one? This one, that is thermal capacity, that is joules per Kelvin into the rise in temperature will be in terms of Kelvin. Let us let it be in Kelvin. So SI unit of heat energy is what? Joules. Kelvin cancels, joules is equal to joules. See, when we solve the problem, if we are putting the formula and if the formula is not correct, then the units in the LHS and RHS will differ. If the units are same, then the formula is correct and the value will also come exactly. The result will be what? Will be in favor of us. Clear? Yes, fine. So this is just a cross verification, just for the continuation part. I hope you understood. So if you have any doubts in these concepts, please let me know through the comment section so that I can help it for you. I hope you understood all the concepts. Thank you. Please subscribe and share it with your friends. So keep encouraging us. Thank you.